Velocity, a vector quantity, has the ability to highly affect the motion of an object. Take this toy car for example. Take a minute and pretend it is actually a boat, and the yellow paper below it is a river. Both the velocity of the boat and the river have been measured by a ticker tape timer. The length of the river is 1 meter, and the starting velocity of the boat is 0 meters per second east. In this first example, the river is unmoving at a velocity of 0 meters per second. The boat accelerates from rest and takes 3.5 seconds to cross the river. The velocity of the boat is 0.29 meters per second east. You will notice that the boat moves in a rather straight line across the river. In this next example, the river is now flowing at a rate of 0.16 meters per second east. The boat is still accelerating from rest to a velocity of 0.29 meters per second east. When two moving components, or vectors, are added together tip to tail, they create a resultant velocity. In this situation, the boat only takes 2.85 seconds to cross the river, because both the boat and the river are traveling in the same direction. Now, in this example, the river is flowing at a rate of 0.16 meters per second west. The boat once again is accelerating from rest to a velocity of 0.29 meters per second east. This time, the resultant velocity will be smaller than in the previous example, as the boat and the river are traveling in opposite directions. Lastly is the movement of the boat when it is traveling perpendicular to the river. The river is flowing at a rate of 0.16 meters per second south. The boat is still accelerating from rest to a velocity of 0.29 meters per second east. The resultant velocity can be calculated using the Pythagorean theorem, and subsequently it is 0.33 meters per second, east of south. The angle at which the boat is moving was also calculated, which means the boat was traveling at a velocity of 0.33 meters per second, 29 degrees east of south. Velocity vectors allow for us to analyze how objects move in certain situations, and ultimately can create more accurate measurements of motions and their paths.